Hello students, let us start with the next module of this chapter, matrices. And here we are going to learn methods to solve linear equation using matrices. So let us try to understand those methods. There are two methods. The first method is method of inversion. Now the word inversion itself states that here we have to use the concept of inverse of a matrix. Now let us move further for the next method. The next method is called as method of reduction. So the word reduction here states that the matrix will be reduced to a particular form using row transformation, and that particular form we will be learning in the later modules. Now here reduction means reducing the particular matrix. So here what we will be learning in this particular module here is the method of inversion, that is method of inversion to find out the linear equations, to find out the solutions of linear equations. Now moving further, let us try to find out the steps first. Consider the linear equations given here. a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. So if I have these three equations with me, I can write the step 1 as follows. Write the equation in matrix form. That is, if these are my equations, then the matrix form here will be like this. First row a1 b1 c1, a2 b2 c2 in the second row, and a3 b3 c3 in the third row. This is the matrix A. Now moving further, the next matrix will be matrix of variables, that is x, y and z. So this matrix is termed as X. And this value will be equal to constants, that is the matrix of constants here, and this matrix d1 d2 d3 is referred to as B. So the equation will be of the form Ax equal to B. Now moving further, if we have Ax equal to B, the step 2 is to find A inverse. Now to find A inverse from the given matrix, we have either row transformation or adjoint method. Now the row transformation we have already studied in the previous module, and adjoint method is also being learned by us. Now the important point is the matrix should be invertible, that is determinant of A should not be equal to 0. Moving further here, the method of reduction, that is row transformation here. Row transformation, these were the particular steps which were involved for row transformation. And similarly, moving for the adjoint method, for adjoint method we had to find out adjoint A, and the formula was A inverse is equal to 1 upon determinant of A into adjoint A. So this was the formula for adjoint method. Now the step 3 here states that if Ax equals to B, then pre-multiply the matrix equation by A inverse. Pre-multiplying means multiplying matrix by A inverse here. So A inverse into Ax will be equal to A inverse into B. Moving further, A inverse into A into X is equal to A inverse into B. Now here taking A inverse into A as one part, and this value turns out to be as I into X equal to A inverse B. Now we know that A inverse into A gives me I, so I into X will now be equal to X, and this value is equal to A inverse into B. So to solve the particular equations using inversion method, what we have to do is we have to find out inverse of matrix A, that is A inverse, and multiply it with the matrix of constants, that is matrix B. So this gives me the value for X. Thank you.